Okay, hi Zach. Welcome to lesson number 90. This is on page 374 in your book if you're following along, and today's lesson is going to be super fun. We're going to jump back into math with doing word problems. I know it's not everybody's favorite, but I actually really like this lesson because it shows you a way to sort of make the word problems easy so that you can't mess them up. Okay, so we're going to do word problems with two statements of equality. It's going to be great. Two statements of equality, so basically two equations, two unknowns. You know how to do those already. You can solve any two equations with two unknowns when you use the process of substitution or elimination. All right, here we go. How I see math word problems. If I have 4 pencils and you have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. Yeah, sometimes I feel like that about math problems, and I kind of do today. So we'll see how my fuzzy mind is going to do with today's lesson. We'll see. It'll be great. Okay, two equations, two unknowns. You know how to do those. You can solve those problems easily as long as you get those two equations written correctly. So that's sort of the crux of this whole lesson, is learning how to pull those two equations out of a word problem, get those right, and then you can just use substitution or elimination and figure out your two unknowns. So, yay! Nothing really new in today's lesson except for figuring out those two equations, which I think is really satisfying to learn. This lesson jumps right into an example, so let's do example 90.1, okay? Here we go. It says, together, Charles and Nell, here's a little picture of them, picked 92 quarts of berries. Whoa, that's a little bit like child labor, but we'll ignore that for now. Okay, Charles and Nell picked 92 quarts of berries. So there's one equation that we can pull out of that right now. If we're talking about the number of quarts that they picked, there's going to be the number that Charles picked, and there's going to be the number that Nell picked, and altogether it's 92 quarts. Okay, so there's one equation. That's the easy one that we can pull out of this word problem already. Okay, pay attention to this next part because this is super important. If Charles picked 6 more quarts than Nell picked, how many quarts did each of them pick? Okay, so let's think about that equation that we're going to write from that sentence, because this is where this is going to separate the smart people from the people that miss this problem, right? And you want to be one of those smart people, because your friends are going to miss this, because the thing that's easy to do, this is the mistake everybody makes, they add 6 to the wrong side. So what this lesson says to do first is write an equation that you know is going to be wrong. That way you will avoid adding 6 to the wrong side. So what they mean by that is this. What if the number that Nell picked is equal to the number that Charles picked? Is it Charles? Yeah, Charles. Okay, so look at this equation right here. We know that this equation is wrong, because we know that they're not equal. It tells us in the problem that Charles picked more. Charles picked 6 more, to be precise. So what a lot of people are going to do wrong is they're going to add 6 to the wrong side. So think about this equality. What would make it equal? So if we actually add 6 to Nell's side, that's going to make it equal. Why? Because Charles picked more. So in order to make it equal, you have to add 6 to Nell's side. You're not adding 6 to Charles' side. He's the one that picked more. Okay, so to make this statement correct, the number that Nell picked plus 6 is going to be equal to the number that Charles picked. And then I can erase this one that's wrong, because I know that it's wrong. That one's wrong. Okay, so now I have 2 statements and 2 equalities, right? And I have 2 unknowns. So I can use the process of either substitution or elimination. So let's just do this first one and just to figure it out, right? So here I have the number that Charles picked, if I plug that into here, or if I plug this into here, then I can solve it, right? So it would be n plus 6, because that's equal to what Charles picked, plus n equals 92. Then I have one equation and one unknown. And you know how to solve these, right? You're going to combine like terms. So 2n plus 6 equals 92. Subtract 6, 2n equals 92 minus 6. And okay, I don't know if you want me to do this whole thing, but I'll just tell you that the number is 43. So this can be 86, then divide by 2. So you get 43 for n, and that means that the number that Charles picked, which is more than that, 6 more than that, is 49. And that's the final answer. But I'm not going to go through all of those problems. This, like the math part of all of them, this lesson is just about getting those equations right out of the word problem. Okay, so let's go on to the next example, which is 90.2. I just realized that that picture is really creepy looking. Like, look at this guy. Ooh, this is creepy. And look at her. Ooh. Ugh. Okay. I meant it to be cute, but it turns out it's a little creepy now that I look at it. Example 90.2 says, the number of boys in Sarah's class exceeded the number of girls by 7. If there are a total of 29 pupils, kids in the class, how many are boys and how many are girls? So I'm going to write the number of boys plus the number of girls has to be equals to 29 because there's 29 kids in the class total. That's the easy part of this problem, right? Because it says if there were a total of 29 pupils. So that's what I pulled out to get this. Now it also says the number of boys exceeded the number of girls by 7. So I'm going to start with a statement that is not true. The number of boys is equal to the number of girls. And then I'm going to think in my head, are there more boys or more girls? It says the number of boys exceeded the number of girls. So there's more boys. So which side do I add the 7 to? I have to add it to the girl side. That way the equality is true. The number of boys is going to be equal to the number of girls plus 7 because there's less girls, right? So write something that you know is false and then figure out which side do you have to add that number to make it true. Now, this part is easy peasy. You have 2 equations, 2 unknowns, and you know how to solve those either by substitution or elimination. Okay, if you do go through the math on this, you'll see that the number of boys turns out to be 18 and the number of girls turns out to be 11. But this is the important part of the lesson, is getting this right. Okay, sweet. Let's go on to the next one. Example 90.3. It says, Philip cut a 38-meter rope into 2 pieces. So it's 38 meters long. There's 2 pieces. And there's going to be a long piece and a short piece. Okay, and it says the long piece was 9 meters longer than the short piece. What were the 2 lengths? Okay, so there's going to be a long piece and a short piece. And let's just call them long plus short. L plus S equals, and we know that the total has to be 38 meters. So long plus short is 38. That's the easy one because that includes this total. Okay, now let's write something that we know is not true. Long is equal to short. Now, the long piece is 9 meters longer. So your dumb friends who are going to get this wrong on the SAT are going to add the 9 over here to the long side. But they would be wrong, right? Because the long side is already longer. So we have to actually add the 9 meters to the short side in order to make this equal. Okay, so hopefully that makes sense. And now, once again, you have two equations and two unknowns, and you know how to solve that. If you do the math, the long piece is 23.5 meters, and the short one's going to be 14.5. But this is the important part of the lesson, so that's the part you want to pay attention to. Let's move on. Okay, now we're getting the groove. We're getting in the flow of these math problems, right? Let's do example 90.4. It says, the sum of two numbers is 72. The difference of the numbers is 26. Ooh, that's interesting. This is a great math problem. I love it. What are the numbers? So there are two numbers. The two numbers add to 72. So let's start with that. Let's see, 90.4. Okay, yeah. So you can call these, what they call these in the lesson is a L for the larger number, and then they call the S for the smaller number. But that reminded me of the previous problem where we did a long and a short piece. But in this example, the L stands for large and the S stands for smaller. Okay, so the sum of the two numbers is 72. That's the first equation that we can get out of this. So we're going to do L plus S equals 72. Okay, that one's easy. Now let's do the second equation that we get out of this word problem. The difference of the numbers is 26. So the difference of the numbers is 26. What does difference means? Difference means you subtract it. So which one are we going to subtract? Is it going to be L minus S, or is it going to be S minus L? Okay, so if the difference is a positive number, that means we're going to subtract the smaller from the larger. So large minus small number equals 26. Okay, and that basically that's it, because now you have two equations and two unknowns. You could also write L equals S. You could figure it out like we have been with the other ones, and say this is a wrong equation and we need to add 26 to the small side, right? Okay, so that is the same thing as the previous. This is equivalent to this because you would just be adding S to the other side. Does that make sense? So you could either write it this way or you could write it this way. These are equivalent, but they will both get you the right answer. Okay, and the right answer turns out is the large number is 49 and the small is 23. Okay, so I want you to think about it one of those two ways. Either write something that you know is incorrect first and then figure it out, or I think in that one the key was to name them large and small, because then it makes sense to say large minus small is equal to a positive number. All right, let's do example 90.5. This says, the greater of two numbers is 16 greater than the smaller. This greater of two numbers, so there's two numbers, a small and a greater, I guess. A small and a greater. So let's name those. S is small. So these are going to be my two unknowns. So I'm just naming the unknowns right there. The greater of two numbers, so the greater one, is 16 greater than the smaller. So let's write something that we know is wrong. G is equal to S. Now, it's very tempting to say, to add the 16 to the greater side, but that wouldn't make sense, would it? Because if I want them to be equal, then I have to add 16 to the one that is smaller in order for them to be equal, in order for the smaller one to equal the greater one. So you could write it like that, either add 16 there, or you could do what they do in the book is G minus 16 is equal to S, because they said the greater of two numbers is 16 greater than the smaller. Okay, so does this equation make sense? Let me know if it doesn't. If it doesn't, text me or read the explanation in the book. It might make more sense that way. But that makes sense to me, to write something that I know is wrong. That is wrong. So which side are we adding the 16 to? We have to add it to the smaller side, or we have to subtract it from the greater side. Okay. And then the next equation, when added together, their sum is 4 less than 3 times the smaller. Whew. Okay, so the second part of this equation, let's change colors because this is getting confusing. The second part, the sum is 4 less than 3 times the smaller. 3 times the smaller. Okay, so let's write something that is wrong. The sum, G plus S, is equal to 3 times the smaller. The sum is equal to 3 times the smaller. I only wrote a part of that equation, so we know that it's wrong. Now it says, let's read it again, because we're going to have to figure out what to do with this 4. So when I read it again, I'm trying to figure out what to do with the 4. The sum, that's this side, is 4 less than 3 times the smaller. So which side is bigger? Is it the sum or is it 3 times the smaller? And I think you can see that 3 times the smaller is bigger, because the sum, it says the sum is 4 less than 3 times the smaller. So we have to, so which side do we add 4 to in order to make it equal? We have to add it to this side, okay, in order to make it equal, because the sum is smaller. The sum is 4 less than smaller. So we have to add it to that side to make it equal. So it's going to be G plus S plus 4 equals 3S. And then you can figure out from the two equations, this one and the one we figured out earlier, this one, that G is going to be 36 and S is going to be 20. But I won't finish that problem because this, like I said, is the important part. Okay, let's go to the next page and do the very last example. Last one. All right, stay afloat with me here. Do you remember that episode? That one was great. I love it. Example 90.6. Here we go. The ratio of two numbers, is 5 to 4. Okay, and the sum of the numbers is 63. What are the numbers? Okay, so there's going to be, first I'm going to define my variables. There's going to be a number 1 and there's going to be a number 2. I think the easiest part of this question is the sum of the numbers is 63. So let's write that equation. N1 plus N2 is equal to 63. Okay, now let's do the harder part. The ratio of the two numbers is 5 to 4. So a 5 to 4 ratio looks like this. And that's going to be equal to the ratio of the two numbers. Like N1, is the same N1, N2. Now, it doesn't really matter. These are sort of interchangeable depending on how you defined it. You can call this like X and Y. It like 1 and 2 sort of implies an order, but there's not really, because it just says they're two numbers, and this doesn't imply an order either. So we don't know which one is bigger, but these are basically the two equations. And the way I solve this is I cross multiply, right? So it's going to be 4 times N1 is equal to 5 times N2. And that's the ratio. So it's this equation and this equation, and that's what you use to solve the problems. And if you do it, N1 is going to be 35 right there. And N2 is going to be 28. So you can do it if you want, but like I said, this is the important part. This and this one especially, because that's really tricky. All right, guess what? That is it for the lesson. So in your room and do your homework now. All right, have fun with your math today, Zach. Love you. Bye.